Hello, everyone, and welcome. Thank you all for joining us today for this live stream event. My name is Rebecca, and I'm the event planner of Microsoft Reactor New York. Before we begin, I'd like to quickly review just two items, our code of conduct and the event guidelines. So for the code of conduct, Microsoft is dedicated to empowering every person and every organization on the planet to achieve more. With that, the reactor is part of this overall experience, and we just ask that while you can, we expect you to contribute in the chat. We look forward to your questions and comments. Please do keep them respectful and friendly throughout, as we don't tolerate any behavior that's harassing or degrading to any individual. So please keep that in mind when you're interacting on the session today. The session is being recorded. You will not appear in the video. The recording will be uploaded to our Microsoft Reactor YouTube channel for on-demand access in a few days. So you can check back there. And I will also drop the link into the chat, so you'll have our YouTube channel for searching out content that we've had in the past. If you have any questions, please drop them into the Q&A at the top right of your screen. Please note that Teams live sessions have a little bit of a lag time in the feed from the speaker to the audience. So if you drop a question at the very end, we may not see it until after the session concludes. So just make sure that as we're going through, you're asking those questions earlier the better. The session does also have closed captioning available. You will either see a CC icon or 3 dots that you can select and then turn on the live captions. So just do feel free to do that if you need it. And then today's session. So we are joined by Pratik Nadagoda and Taysser here today with us from Microsoft for an intro into Git and GitHub for Visual Studio. This session will run for approximately 60 minutes with time for questions throughout. If you have not done so already, I shared in both the chat and on the screen earlier our check-in link. This link has session resources related to the topic, so do feel free to check in. We'll also be sharing those links soon enough in the chat as well. At this time, I will pass the mic and the floor to our presenters today. Welcome, everyone. So.
Thank you. Hi, Rebecca. Thank you.
Hey, thanks. Thanks for being a part of it.
Of course, of course. This is going to be fun. We're excited to introduce you all and help you all with getting started with Git and GitHub and Visual Studio. So I'm going to go ahead and share my screen. Yeah, so today we're gonna go through a getting started learn module for learning how to get up and running with Git and GitHub as version control systems in Visual Studio. If you want to follow along, you can go to the AKMS link we have on the screen, ak.ms/vs/get-started, Git and GitHub. We'll also paste a link in the chat for you to click on it and follow along as we explore and learn how to use Git and GitHub in Visual Studio. So just to start off with, let me take you through kind of an overview of version control. So Git is a type of version control system, but version control is not only Git, right? It's the point of version control, or source code management systems, as they're called, is to be able to track your changes in code, be able to go back to previous versions of your code and have backup copies of the code or any kind of work or documentation you're doing online, and be able to do that in a professional way. So it's a great skill set to have. Employers are looking for it, and using version control is a default method in the industry to make sure that you are tracking your code and have good practices and policies in place to make sure your code is at good quality. It's also important and very valuable in sharing and collaborating with others. So on Teams, version control systems are widely used to make sure that everyone is up to date and has the right version of the code. So there are two main different types of version control systems. The first one is centralized version control systems. The examples of these are Perforce, Subversion, and Team Foundation version control, just to name a few. And the main benefit of these types of version control systems is that there is a single source of truth. So all of the code or the files that you're working with are stored on a single server, and that is the source of truth for the code. If I want to change a file, I have to check out that file so that no one else can touch it or mess around with it. And then when I'm done working on it, I'll check it back in to that single source of truth. But there are some disadvantages of centralized version control systems, and that's where distributed version control systems come into play. Centralized version control systems need an internet connection. And because there's only one source of truth, if that gets corrupted, then you kind of have lost your code. But distributed version control systems don't need an internet connection. You can have multiple copies of your code all on different machines with different people. You can pass them around on a pen drive or via email, and everyone has their own history and everyone has their own backup of that code and can make changes to the code. And you can have multiple clones of it. So the examples of these are Mercurial and Git are a couple examples of distributed version control systems. And Git is being widely used in the industry now as almost a de facto version control system. So the next part of this is cloud platforms for Git. So there are different cloud platforms that are basically containers on remote servers that can host your code. And so GitHub is one that's very popular, that's built on the principles of Git. Azure DevOps is another, GitLab is another, and Bitbucket as well. And these are different cloud hosting providers where folks can, and teams can, and individuals can store their code and always be able to access it in different from different locations. And so we'll go into how to do that, how to use Git, how to use GitHub, and how it makes your life a lot easier when you're coding on a project. So let me first go to Visual Studio. So I have Visual Studio open in front of me. This is an instance of Visual Studio 2022. And this is a new version of Visual Studio that we just released last month. It's in preview right now, but it is installable and downloadable to anyone who wants to use it. The big difference of Visual Studio 2022 is that it's 64-bit. So Visual Studio 2019, which is the generally available version, is 32-bit, and so with the conversion to 64-bit Visual Studio, that means it can use more memory and there's less out-of-memory exceptions that may happen. And so it may seem a little bit faster to you. So you're free to use Visual Studio 2022 or VS 2019 for this workshop. They have the same Git functionality, and so you can use one or the other. And so I have VS 2022 installed. This is the community version, so it's free for everyone to use. I don't have to pay for it. I just need to sign in, and I can use it for forever, as long as it's installed on my computer. So I've signed in. I've gone ahead and signed in. You can see my initials on the top right of the screen. If you aren't signed in, if you're following along and you haven't signed in, then you can click there's a sign in button that should appear here on the top right. You can click that and sign in with your Windows account. You need any Windows account that you're signed into on your computer can log into Visual Studio, and that is the license basically which Visual Studio is then related to. So if I go into account settings after signing in, I can see that this product is licensed to my work address right now, and that's my personalization account. That's the main account that I have logged into Visual Studio in. But in addition to this main account, there's also a set of other accounts that have also logged into Visual Studio. These are my personal accounts or my work accounts or my school accounts that I can all link to my personalization account, and these become part of my Visual Studio keychain. The advantage of this is that now these accounts, if they have access to other resources or other credentials, then I automatically get that in Visual Studio. Visual Studio also understands that these accounts exist, and if I need to connect anything on Azure, I can do that here, and I can easily add or remove different accounts through this button here. And so what we also have here is the ability to add a GitHub account to Visual Studio. So I'm going to go ahead and do that now because we're going to be working with Git and GitHub. The first thing I'd want to do is sign into GitHub. So Visual Studio recognizes that I'm a GitHub account holder, and I can sign in and see my resources and my repos on GitHub. So I'm going to click sign in. And what that's going to do is going to sign me into GitHub. It should for you open up a browser. If you're already signed into GitHub on your browser, it should automatically, Visual Studio just automatically recognizes that and does a single sign on and signs you into Visual Studio. So now you can see that GitHub is here. If you don't have a GitHub account, it'll take you through the process of signing up for GitHub, which you can do with any email address, and then link it to Visual Studio by attaching that account and adding that to your Visual Studio keychain. So cool. So I have this account here. So I'm going to close this out. And just to recap that, going back to the slide deck, I have a single personalization account, which is the account I'm signed into on Visual Studio. And part of my keychain, I can have multiple different accounts, my Microsoft Work account, a school account, personal account, and also a GitHub account, which are all part of the keychain in my personalization account. So with that said, I'm going to go back to Visual Studio now. And what we're going to do is, since we've signed into GitHub here, we're going to start with creating a new repository. And the best way to do that with Visual Studio is to start with creating a new project. So I'm going to go to File, New Project. And what that's going to do is open up the Create a New Project dialog. This dialog is the home for all the templates in Visual Studio. So Visual Studio has a collection of different types of templates in different languages. And these templates help you get the scaffolding ready for your project, for any kind of application that you want to build. It gives you the base files that you need so that you can start running the project immediately in Visual Studio. So I'm going to select the first one here. This is a console application in C#. It runs on Linux, macOS, and Windows, and because it's based on the .NET Core framework. So I'm going to select the console application and hit next. Let's name that application. So I'm going to name it Learning Git as the project name, and that becomes a solution name as well. Save it to my repos on my local disk. Hit next. And then select the framework version. Here, since I'm using Visual Studio 2022, I'm using .NET 6 Preview. If you're using a different version of Visual Studio 2019, for example, you'll get different options here, and it's fine to select the default one. And I'm going to hit Create, and that's going to create this console application for me in that local location on my disk. It's going to create the project. It's going to open up the project in Visual Studio and tell me and show me where it is. So here I have the solution open here in Solution Explorer. And so this is the Learning Git solution. I can see the project that I have, Learning Git, and the program.cs file, which is the default file. Right now, it just has a single console.writeline for hello world. And that's OK for now. So we're not going to make any changes here. So this is a project. It's a set of code files that are local to my disk. It just exists on my local machine, but I want to start tracking them in version control. So if I make any changes, Git will understand those changes and I'll be able to go back in history and see all of the changes that I've made once I start working on this project. So I'm going to do that right in the beginning. And so to do that, I'm going to open the Git changes window in Visual Studio. So I opened that from the Git commit or stash, or you can also go to the view menu and click on Git changes. And that will open up this window here, which is kind of the home for your status, your Git status, any changes to the files you're making. And Visual Studio understands that and shows them in this tool window here. Right now, since this project isn't under Git, it doesn't have any information. It's telling me to create a Git repository. So that's what I'm going to go ahead and do. Usually creating a Git repository involves a lot of steps, but Visual Studio makes that very easy by just a single click action for creating and pushing this to GitHub. So let's walk through this dialog here. So this is the create a Git repository dialog. In the left section, there are different tabs. So push to a new remote lets me select GitHub and allows me to create a repository and push it to my GitHub account, which I've already signed into. If I select existing remote, that will let me create this local Git repository, but push it to any other remote. Say if I have a repository that exists on GitLab or Bitbucket, or even hosted privately on a server that I own, I can push my repository there and have it stored there. I can also create a local only repository. So if it's local only, I can track changes, I can see the history, I can revert any changes that I make to my project, but this is only local to my machine. It's not backed up in the cloud. It's not shareable really unless I copy it and email it to somebody. So for this exercise, let's select GitHub here to push this repository to GitHub in one go. And so since I've signed in, this is my GitHub account, which is already visible here, as well as my owner username. And it's picked up the repository name from the folder name. I can add a description. The description is optional. So this is a sample repo to learn Git. Let's call it that. And then there's a checkbox for private repository. So by default, any repository I create on GitHub will be private. What that means is that nobody else can really see it. If anyone wants to see my repository and the code I have there, then I need to exquisitely give them access. I need to tell them and give them collaborator access so that they can see the code and make contributions to the code. If I uncheck this box, what that means is it makes my repository public, and that's where it is visible to anyone who goes online and searches for my repository on GitHub. But no one can still make changes to it and edit it. That's still something I need to explicitly give them access to do. So a lot of people think that GitHub is all about community and open source and sharing code where it's all public, and that's true. GitHub does promote that, but you also have the ability to have completely private repositories that is only your code and only you can see, and it's very safe and secure. So we're gonna create a private repository, and I'll hit create and push. So that's gonna create the repository on GitHub and push my code to it. So I'll go back to what that all does. So all of the steps that Visual Studio is doing for me right now is it's starting with creating the repository on github.com. So where I have my account on GitHub, it's going to create the repository for me. It's going to take the URL of that repository and bring it local. So it's going to initialize the repository in a local place for me so that Git understands it. It's going to link the remote and the local for me. It's going to add some metadata files for Git that are good to have, that tell you what files to track, what not to track, and how to do that. It's going to take the files that I have in my project, in my Learning Git project, the program.cs and the .sln file. It's going to stage and commit those files to Git. So Taysser is going to go into the process of staging and committing in a lot more detail in a bit here. But Git is doing that for me, and Visual Studio is doing that for me right now. And it's going to push that repository up to GitHub with all the files that I've added. So just to show you how that looks. So now you can see that the Git changes window is populated. It has a bunch of information and context of which branch I have and different actions I can take here. But the first thing I'd want to do is I'd want to click on this overflow menu and click on open in browser. So I can see that this repository is actually there. So if I open my browser, I can see that this repository is available on github.com. It's called Learning Git. It's a private repository, and it's hosted here. So I always have a backup of my repository now available on github.com. And the advantages of this is if I ever lose my laptop, for example, or I have to reformat it, and or I'm on another machine and I don't have access to my laptop, I can always get my code files. I can always download them or clone them, as it's called, from GitHub. And Visual Studio has an easy way to do that. If if I go to the file menu and click on clone repository, I can select GitHub here, and that will give me a dialog which has access to all my remote repositories because I'm signed in, and I can select Learning Git as my remote repository and clone it down to my local machine in wherever I am. So that's the basics of getting started with creating an account and creating a repository on GitHub and in Visual Studio. I'm going to now hand it off to Taysser so that he can kind of go through the next steps of what you can and can't do with your repository in Visual Studio.
Cool. Thank you. Thanks, Pratik. So let me share my screen. Cool. Hello, everyone. This is Taysser here. So Pratik walked us through the basics of how to get started with Git and GitHub inside of Visual Studio. And I'll dive deeper into some of the details here. So what I would like to get started with is how Git is tracking your changes in general. And so in this case, as you can see in the slide above me, all the changes that you make are tracked as snapshots in Git. And so those snapshots are called commits. So basically you can, as Pratik mentioned earlier, you can go back to the previous commits and that creates a great history for you to reference and get back to. So basically your Git repository contains a number of commits, and those commits are the snapshots of your code that you are making over time. In general, there are three main states of your files in Git. So like there is the working directory, there is the staging area, and there is the Git directory or your Git repository. So the repository, as we mentioned, like it has all of the previous commit that you made. It contains your history. It is what you can store in GitHub. It is basically the source of truth. Once you clone that repository, as Pratik showed us, you can actually start to work on that repository. As soon as you start to make changes to your code, you are basically making those changes in the working directory over there, right? So let's say you made some modifications to your one of your files. Those modifications will be a part of the working directory. And then you can choose to utilize the staging area. The staging area is an optional area in Git, and it basically helps you to prepare for your commits. So the way that works is, let's say you are working on a new feature or you are trying to fix a bug, and so you can make a number of changes and then you stage them. You continue to make other changes and you stage them, and then at a specific point in time, you can look at all of the changes that you have been making in the staging area, and then once you feel good about them, you can go ahead and commit from there. But that is 100% optional. You can actually commit your changes right away without utilizing the staging area, and I'll show you guys how you can do that with Visual Studio. So this is basically the very basics of how Git is tracking changes and how commits work. So let's switch to Visual Studio very quickly and see how that works over there. So I've been actually following and following the steps that Pratik showed you, and so I am on a very similar project. It's a similar Git repository. I've been following the same steps that Pratik showed you. So this is my solution explorer. I have program.cs open here, and if I click on changes, the changes tab that Pratik showed us, you can see that it has different sections, right? There is the changes, which is empty. There is an empty text box here. We call it the commit message box, and there is an upper section here that shows you the status of your repo. So we'll get into this in a minute. But then let's say you would like to work on a new feature, or you would like to make changes to this code here. So in this case, I'm just going to be copying this line of code and pasting it over there. You can see as soon as I made that change, the Git changes window recognizes that, and it is showing that file over there, right? And this is basically my working directory, right? So I have introduced the change and it is showing over there. And that is basically this first part, the working directory, right? And then I can actually move this this change that I introduced into the staging area, right? And the way to do that, I can move all of the changes in the working directly using this plus button up there, which it says, you know, stage all, or I can stage file by file. So if I click the plus, what that will do is it will actually move the changes I made to the staging area, right? So it says stage changes, and that is basically the staging area here. So let's say, I'm still working on my my changes, and so I would like to further customize this and say, for example, we are learning Git, right? I'm saving it. You'll see now the change I made is shown in the working directory here, right? So basically I have changes on both the first working directory and the staging area, right? If I right click on the working directory, I can actually compare, right? And what that would do, it would actually show me the changes that I have been making, right? I have these changes showing in line, but if I want, I can actually see these changes side by side, right? So I can very quickly see, okay, like this is what the code used to look like, and this is the change I made. We are learning Git in that case, and I can switch between side by side and line by line or inline diffing using this drop down up there. So to move the changes to the staging area, I would just need to click one of these pluses in that case, right? And once I do that, you'll see that it combined all of the changes in program.cs. Actually, if I right click and do another compare there, it will actually show what I have in the staging area. So let's go ahead and now commit the change. Committing the change basically would move your staged file to the Git directory or your Git repository, right? So let's say this is our first commit. And then basically click on commit stage, and that would go ahead and commit the change. And you'll get this confirmation up there, and your changes are cleared up because you have actually committed that change you made. You might notice that now it says 1 outgoing, 0 incoming. We'll get into that in a minute. But now what I want to further talk about is actually, what is called the file status. So we talked about the file state, which can be, your files can be in your working directory, they can be in the staging area or the Git repository. But then those files can be in different states or status, right? In those different states, your files can be added, deleted, or modified. So to further explain what's going on there, let's get back to Visual Studio and make some tweaks there. So if I add another line here, you might see that program.cs now shows there, similar to what we saw before, and I get an M letter on the side. If I hover, it says modified. That means that I have actually modified that file, right? But sometimes you want to add a new document, a new file, and one of the easiest way to do that in Visual Studio is to right-click on the project and then go to Add, in this case, new item. Let's try to add, for example, a new class. I'm clicking on the class and click Add there. So you can see that now Visual Studio added that class. This is the class I have just added. And if I go to the Git changes, I can see that the class shows there and I see an A letter on the side. If I hover, it says added, right? This is indicating that that file has just been added, but then I have been making some modifications or changes in the program.cs. So now let me let's make a commit. Let's say added a new class. So we made it that commit, and now it says 2 outgoing, 0 incoming. What about deleting a file, right? Like, let's say you didn't really want to add this class, you changed your mind. You can always right click and delete. Confirm that, okay. And so the class now is gone from Solution Explorer. And if I jump back to the Git changes, I actually see that class and it says I get the letter D. The letter D here is saying that that class has been deleted in this case, right? So those are the main different types of files, or the main different statuses of the files that you are tracking in Git. So the file can be added, it can be deleted, or it could be modified. Those are the three main ones. Another thing to talk about here would be like managing your changes, right? So we have been making changes, as you saw, and Pratik mentioned earlier that one of the great things about Git is that it allows you to, go back to your changes, manage them, tweak them, all that, right? And then there are different ways to basically manage your changes in Git, and that depends on where your changes are, right? So we talked about the three different states of your changes. So your change can be in the working directory, the change can be in the staging area, or it could be in the Git repository, right? And depending on where the change is, the method of changing that change or tweaking or modifying the change would depend, right? So we'll go over some different methods here. So for example, if the change is in the working directory, then Git would allow me to undo my change. So if I hop back to Visual Studio here, you can see that we actually deleted the class, and that deletion is now a part of my working directory. I still haven't staged it. It is not a part of the repo. It is still in the working directory. The easiest way to undo that, let's say that was a mistake, I can actually click on this arrow and it says undo changes here. If I click on it, I get this confirmation. Are you sure you would like to undo your pending changes? If I say yes, then that would disappear from my Git changes. And if I go back to Solution Explorer, actually you'll find that the class has been added back, right? So in this case, like the change was just in the working directory, and so to undo it, we just undid that change, and that brought that back for us, right? Sometimes the change gets further into the flow, right? Like you might have been working on a feature or trying to fix a bug, and you have been making tweaks or changes to a different number of files, and then you find that, oh, actually I didn't intend to include this change in this commit, right? So what do you do there? So if we can go back to Visual Studio, let's assume that we actually wanted to delete that class. I'm deleting that class second time here. You'll see that that change or deletion is now a part of your working directory. Let's stage it. So if I click the plus, now that is a part of your staging area, right? Let's introduce another change to program.cs. So previously I added this line, empty line of code. Let's get rid of that. Saving the change. And now let's say I would like to, stage that too. So let's assume that now, while you're preparing for your commit, you would like to separate those two, changes, right? You don't want to like introduce a commit that includes the deletion of the class and the tweaks that you have been making to program.cs. The easiest way to do that would be to unstage the change that you made, right? And in this case, I can use the minus in this case, and that will move the program.cs out of the staging area back into the working directory. And so I can go ahead and commit. So let's say deleted my new class. And if I go ahead and commit, you'll see that my program.cs and the changes I have introduced there are not a part of this commit, right? If I right click and do compare, you'll see that actually let's go side by side. You'll see that that hasn't really been a part of that commit that we have just made. It is still a part of my working directory. So that's the second way that you can use to manage your changes if they made it to the staging area. Well, sometimes your changes actually made it to the Git repository itself. So let's say, in this case, we have deleted the class, we committed the deletion. So that deletion now is a part of my repository. How do I undo that, right? There are different ways to you can use to undo that change that you made. Let's take a look at those different ways that allows you to undo that. So let me actually, before I do that, let me show you something. Earlier, we talked about not having to use the staging area. So we said that you can actually commit your changes right away, and you don't really have to use the staging area. And so in this case, like I have my program.cs in the in my working directory. And so if I want, I don't have to use the staging area. So I can commit that change right away. So changing can commit all, and what that would do is actually commit my changes right away without actually using the staging area at all. So let's say I actually made that change, committed it. We have removed the line here, but like I forgot to add something, or I did something very quickly and I didn't realize that I should have added a something or a tweak. The easiest and the quickest way to undo what you have just committed would be to utilize the amend, right? So the way to do that, let's say in this case, I actually meant to remove the extra line, but I should have also added some comments, right? So this is a comment, right? Let's assume that I actually wanted this to be a part of the previous commit that I made. So you can make that tweak in your code, and then you can use the amend button here. What that amend button would do is it will actually go back to the previous commit you made, and it would allow you to further tweak it, right? I can tweak the commit message itself. So we can say by adding a comment, right? And you can also add other files, make other changes, and all that is going to be a part of the same commit. So if I commit all, you'll realize that it actually didn't add that number. We still see 4 outgoing commits in this case. And that is basically updating your last commit using amend, right? So this is very helpful if you have made a mistake, or if you in your commit message, or if you forgot to include a change that you meant to include at the beginning. The easiest way to deal with that would be to amend the previous commit that you have made. There are 2 other ways to actually go further into your Git history and make further tweaks. But before I get into those, I would like to show you your Git history. So we have been actually, making changes, tweaks, and committing and all that, but we haven't really looked into our repository. And so the easiest way to get to that is actually by clicking on this 4 outgoing, 0 incoming link. If I click on that, that will actually open my Git repository. And your Git repository, has 3 different sections. There is an incoming section, which shows you any incoming commits. We are not really covering that today, but this can be very helpful if I'm collaborating with someone else, or if you are working on your code from different machines. So you can make sure that you are including the changes that you are introducing to your repository, the remote repository in this case, GitHub, for example. Your outgoing section basically includes all the changes that you have been making locally, but those changes haven't really been pushed to the Git repository online, in this case, GitHub, right? So all of these 4 changes are the local changes that we have been committing together. So this is our first commit. This is the first commit we made, added a new class, and then we deleted the class, changing program.cs, so on and so forth, right? And these are the original changes that Pratik walked us through, right? This is when we added the Git repository and pushed our changes to GitHub. That is why those 2 are not a part of the outgoing section. If you click on any one of those commits, what Visual Studio would do is actually it will open what we call the commit details, and it will also show you a diff of that commit. In this case, this is the commit where we deleted the new class. And so you can see that that class is highlighted as deleted, and the diff is showing or summarizing the lines that got deleted. So in this case, we deleted the whole class, so the whole 12 lines of code got removed. If I click on another commit, Git will, or Visual Studio in this case, will show or update and show the commit details there. You'll see a summary of all the changes that we have made. Make it bigger. In this case, we changed program.cs. We removed this new line and we added this comment. And so this is a really nice way that you can, look at your history and, understand what's going on, and understand what the team is also have been introducing. We talked about going back, so we actually talked about 3 different ways that you can use to go back and tweak and change the changes that you have been making. We haven't really talked about resetting and reverting yet. So reset is actually a destructive command in Git. We call it destructive because it actually tweak or changes your Git history. In Git, history is very important, especially if you are working in a bigger team. Maintaining that history over time is important because other team members might utilize parts of that history and they might build on top of it. And so reset in that case can be very disturbing to other team members because you might end up deleting a commit that someone else has been using or building on top of. So if you are a part of a team, and especially if you have pushed your changes, and we'll get to pushing in a minute, we highly recommend you to use revert instead of reset. So revert wouldn't really delete any previous commits. It will actually create a new commit for you based on a previous commit. So if we go back to Visual Studio and look at our history, if we would revert, for example, based on this commit, you'll see a new commit that gets created above, and that commit is based on this one. But in this case, we haven't really pushed any of our changes, right? And so let's say, we want to go back, and it's totally fine. We are not worried about harming others because those are still local changes. Let's say since we have deleted the class, that is a change that we haven't really intended to do. So to undo that deletion, the way to do that is basically you would have to click on the commit before the commit that you deleted the class at, right click on that commit, go to reset, and then choose delete changes. The difference between keep and delete is basically whether you would like to keep the changes that you have introduced in that specific commit. In this case, let's, we actually added the new class there. And so let's assume that we would like to, keep those changes. So I'm choosing to keep the changes. And so now you can see that this is the commit that we went back to. And this is the class that we actually deleted. And because I chose to keep the changes, Visual Studio and Git in this case kept the changes that I have been making after that commit, right? And the change there was to delete this class. So in this case, I can undo this deletion if I want. This is just a confirmation. And then I can choose to keep the changes I have been making to program.cs. To confirm what those are, I can right click. I can compare with unmodified. So this is basically when we added the comment and removed the new line. And so I can say, cleaning up program and make my commit. Right. So if I close this and go back to my Git repository, you'll see now that I have this new commit. And these are the 3 different commits that we have introduced in this case. The last thing I want to show you today is actually how do we push these commits to GitHub. So we have been working locally all this time. Pratik mentioned that one of the main benefits of using GitHub would be to, store your changes in a remote, safe place. So God forbid your machine, is lost or something. All of the code that you have been working on is still accessible on GitHub. And this is also a great way for you to work on different machines and even collaborate with others on your project. So the way for you to push these changes, you can actually click the push button here on the Git repository window, and that will push these 3 commits. Or I can actually also use this push button on the Git changes window, which will do the same thing. So I'm clicking that right now. And Visual Studio is working on it. It says initializing push. Let's give it a minute. Depending on the amount of changes and depending on your internet connection, this can be quick or it might take some time. So, I get this success message. I can, create a pull request, which is an advanced topic. We'll not really get into that today. But to confirm that your changes have been pushed to GitHub, you can use the drop down here. You can use the open in browser, which will open your repository in the browser, similar to what Pratik showed us earlier. And you can see that your changes can, be a part of what you have pushed. So yeah, this is pretty much covering what we would like or what we wanted to talk about today. And let me now hand it back to Pratik to close the session and answer any questions that you guys might have. Pratik?
Thank you. Yep. Thank you, Taysser. Going back to the end of the slide deck, we went through a lot of stuff today and a lot of great questions. In the chat, there were some questions about the staging area and the difference between the staging area and the working directory. So that's something that Taysser explained in this conversation, where the staging area is used when you don't have you don't want to commit all of the changes that you've made. Say you've made changes to 20 or 30 different files, and they're all good changes that you want to commit in your repository, but you don't want them to be all in one commit. You want to separate them out in different commits so that they're in good chunks of commits. And so you can say, hey, this commit is related to this feature, this bug fix, or I added this functionality with this commit, and you can take maybe 5 or 10 of those files which are related to that, and then stage those files and then just commit that in one go. And then you can do that with the other changes you've made and pick which files you want to commit. So the staging area is used sort of as a preparation area for what you want to be included into your commit. And that's the difference between your working directory and your staging area there. So that was one of the questions there. There was also a question about keeping changes in reset and revert. So Taysser, maybe you want to spend a minute or so with explaining the difference when you're resetting and what happens when you delete changes and what happens when you keep changes.
Yeah, absolutely. So let me share maybe my screen one more time. Okay, cool. So if you guys remember, what we ended up doing, like we deleted the new class we added and committed that. But then with that commit, we have also been tweaking program.cs. And so what we wanted to do is to undo the deletion of the new class, but then keep the changes we have been introducing in the program.cs, right? And so that's why when I, right clicked on that commit, I chose, reset and keep changes. That allowed me to further get into the different changes we have been introducing after the commit we went back to, right? If you remember, we got two types of changes, the class that we deleted and the program.cs one. I discarded the class, the deletion of the class, and kept the program.cs tweaks, right? This further allows you to tweak and customize what changes you would like to remove and what changes you would like to keep. If I end up choosing the delete changes, that will just discard all the changes that I've been introducing after that commit, right? So, for example, if I click on, this is our first commit. You'll see here that this includes the program.cs. These are the first changes that we added together, right? We are learning Git. If I right click here and choose reset, delete changes, hard reset, right? What will happen after getting the confirmation? Are you sure you want to reset? Yes. What will happen there is that you'll go back to this commit and Git will discard any changes that we have, introduced to that commit, right? So let's see here, right? You'll see that the Git changes is empty. There are no commits or no changes, and so the changes that we made after this specific commit are lost, right? So this is helpful if you're trying to, go back to a previous commit and you're not really interested in the changes or the modifications that you have been making to that commit that you are going back to, right? So, and that's basically the difference in this case. Back to you, Pratik.
Yeah, awesome. Thank you, Taysser. There's also another question: what's the difference between push and commit? So I can briefly explain that. So when you commit, you're basically taking changes and committing them to your local Git history. They're in your local Git repository, and they stay to your version of the Git repo where the code lives. They don't really go to anyone else at that point in time. They're all with you and locally with you. But if you do want to share that, if you want to publish that, then that's when you push. That's when you click on push your changes, and as Taysser showed, once those changes are pushed or those commits are pushed, they are then on GitHub, and then other people can see those changes. If you have collaborators or other team members working with you, they can see those changes that you've made and the commits which you've made them in only after that code has been pushed up. Yeah, so that is kind of the conclusion or the summary of what we wanted to show you guys today. It's a lot to take in, a lot of content, and so we didn't want to put too many concepts into one single session. But we would like to host more sessions and help explain whatever we can in further sessions. And so if what we would be great is if you guys could share your feedback with us. We have a form available on https://ak.ms/vs/git speaker feedback. And the link is in the chat as well. And if you can share that feedback of what you would like to see next, what went well, what didn't go well, that would be great for us. There was a comment in the chat about pull request support. So if you guys want to hear us talk about how pull requests work, we'd be happy to do that in an upcoming session. Just let us know. And that would be great for us to hear. We also have our docs, our version control docs available, ak.ms/vs/version control. That's where you can see all the documentation on Git and GitHub functionality in Visual Studio. We're constantly updating the docs as well. So if you're confused about something or something doesn't make sense to you, we'd be happy to elaborate and expand on that in the docs, because they are definitely a work in progress as we're building out new functionality for Visual Studio and Git. And then if you want to see what we're building next, what more features we're integrating in Visual Studio, then you can look at our roadmap, ak.ms/vs/git roadmap. And so thank you so much for the questions and for attending the session with us. I'll hand it back to Rebecca.
Hey, so Jay Chris unfortunately had a little bit of trouble connecting to this session, and he threw out one last question. I don't know if you have the opportunity to answer, if you're familiar with what is stash. I don't know if you want to.
Oh, okay.
Sorry
sure.
about that.
Yeah, no worries. I did not see that. Yeah, so a stash is another Git concept. We didn't go into that in too much detail right now, but basically what you can do with a stash is take a set of changes and save them for later. So they are changes that you've made, but you don't want to include them in what you're working on right now. Say I was working on some code and I was building out a new feature for my application, and I realized that customers or my clients are having an issue, and I'm like, no, I need to fix this issue first. So I take the changes, I'll stash them, and Visual Studio has UI to help stash your changes and see them. And then I can work on the bug fix and resolve the issue, make changes there, commit those changes, push those changes. And then after I'm done with that, then I could pop out my stash again. And so those changes which I had made previously on the feature I was working on get popped back up into my working directory. And so a stash is just an easy way to save your changes for later if you don't want to work on them right now, and then get them back later. Yeah.
Awesome. Thank you. He followed up. Sorry. What is a shelf set? Do you?
Yeah. So a shelf set, I think,
really getting into it.
Yeah, that's okay. That's okay. And Taysser can correct me if I'm wrong here, but shelf set is the same concept as a stash, but it's used in Team Foundation version control. And so it's a similar concept, but because of different version control systems, there's different terminology used. Anything to add there, Taysser?
No, that's exactly right. In Git, shelf sets are basically stashes, so it's a way to as you said, to store your changes to come back to them later. So let's say you're working on a new feature and you get an emergency bug that you need to address. You don't really have to discard your changes. You basically stash them or save them for later. You work on your new feature or your bug fix, and then once you are ready to get back to your work, you can pop or apply the stash that you made, and that would allow you to go back to what you were working on. Another way to manage this is also by using branching. We haven't really been into branching during this session, but that branching also allows you to have different different versions of your history, which can be very helpful when it comes to like having to work with different features or having to like address an immediate work and come back to, you know, the previous work. Branching can also be another great way to deal with that. But yeah.
Awesome. Thank you so much, both of you, for taking that extra time and answering those questions. I'm just going to share my slide here for a second. Just bear with me one moment. So you can take your slide down, not have to worry about that. So again, thank you so much, Taysser and Pratik. This was amazing. Thanks to the team as well, everyone helping answer the questions in the chat. We had a lot of engagement. Absolutely love it. This was a wonderful topic. I think there was a lot of people super interested in it. Lots of questions and learning opportunities there. I dropped a lot of links into the chat. So there's a lot of like intro how to, the Learn module itself, their roadmap. So all of those links, just scroll up in your chat. They should be there. If you do have the opportunity, please submit that feedback survey. We'll use that for future planning. And then also, if you are new to the Reactor, we have content rolling out every week, new and great stuff. We're always updating our calendar. If you joined us through Meetup, or if you're not yet part of Meetup, it's a great place for the tech world and a lot of developers and startups and things to meet and get some good content building skills up there. Lots of free stuff always coming out. Also, our main website, microsoftreactor.com. Do check that out. You know, depending on where you're joining us, one time zone might work better than the other. So that's a good place to kind of sort through all the different locations that we have. We have 11 physical spaces around the world. And now with COVID kind of winding down in some places, we're able to open some of those in-person sessions back up as well, which will be coming soon. And otherwise, we continue to have all of these wonderful virtual sessions and some great speakers and amazing content coming through. So do feel free to check out, you know, our calendar, and also I dropped in the chat, this is part of a series, the app development series. So there's a few more sessions coming up for that as well. Awesome. So at this time, I'm going to once again say thank you both. This was a great session. This session will be available on YouTube on demand. They have a playlist on our Reactor YouTube channel. So this session will pop up there probably in a couple of days. Thank you all so much, and have a good rest of your day.